Okay, let's continue and see a couple more practices or a couple more operations that we can do on the list, but we cannot do on tuples. Well, the next thing I want to show you is extend. So for the extend, this is similar to the list concatenation, and that is we have a list and then we want to extend the list using another list to be appended or to be attached to the end of the existing list, which is this one. Okay, and say if for this list I want to extend it using 3 more items from the list of the 9, 8, and 7. So now if I'm doing a extend and then I'm printing that, and then you can see this change has been done, and it has to be done in place because it is still the same variable name Li for this, right? So well, this extend can we have something similar to on tuples? The answer is we can't because we are expanding the list in place by extending that and adding more items, right? Well, and be careful. There's a difference between extend and append. So for example, if we want to use this list and then you want to do an append, and what will we have? We will have the 10, 11, and 12 as one single member, because when we are doing appending, we are adding only one item to the end of the list. So if you do extend, you are extending a list using another list. So you are going to get a result of a concatenation. However, if you want to do a if you want to append a list on another list, and then the list will be appended to the another list as one last member. So you are building a nested list. So those two are different. But anyhow, well, it doesn't matter for append or extend. We can have that on lists, but we cannot have them on tuples. Why? Because we cannot make any in-place changes on tuples. Okay, and here are some of the operations that we can do on the tuples. So let's see. Well, for the first one, if you want to get the list.index, so you are getting the index of the first occurrence of the B, and then you will get the return of 1 because on index 1, and I see the first case of the B. Okay, that if we want to do the similar thing for tuple, can that work? Think about it. Well, we know if we are doing the dot index and a certain value, and then Python will show us the index of the first occurrence of such a value in the list. Can we do the same thing for tuples? The answer is okay, we can do that. Why? Because we are doing a search. However, we are not making any in-place changes. Okay? Well, how about the next one? How about count? Say if I want to count how many of the B occurrences on this list, and then I'm going to get a 2 because there are 2 B's, one here and one here. Okay? Well, if we change it to a tuple, can I do the same thing? The answer is yes, because again, we are doing a search and counting. However, have I done any changes to the list or a tuple potentially? Well, no. We are only doing a scanning, right? And next thing, how about a list.remove? We are removing the first occurrence of B. Well, in list, that's fine. And then we are going to have the first occurrence of the B removed. And my question is, again, can we do that on tuples? In this case, nope, because this is indeed a in-place change because we are throwing some of the values away from the list. If we are doing that from a list, that is fine, but we cannot remove any item by value on a tuple, right? Okay, and the next thing, reverse. Well, in list, we can do reverse. That is the list and then dot a reverse. And then we have all the values flipped. So in list, that is fine. But can we do that in tuples? No, because that is a in-place change, right? And then the same thing for the sort. Well, we can sort a list, and then this sorting is also in place. And we know that as long as this operation is done in place, well, we can do that on a list, but we cannot do that on tuples, right? Okay, and then, well, here are a few more things I want to say about the list versus the tuples. Well, for the list, well, it is more flexible, but you need to understand that to make the list flexible in Python, there is a cost because the list will be slower. However, I would agree the list will be more powerful in Python. So that's the reason that we are using the list quite a lot, but we don't use the list we don't use the tuple so much. Okay, well, and and there will be cases that you have a list of the values and you want to put it into a tuple to have the values kind of protected. Okay, and then there will be a something reverse, like if you have a tuple but at some point you really find that you have to do some changes to the tuples, and then you may have to convert that to a list so that you can do some of the changes. So you may have to cast a tuple into a list, or a list to a tuple, and then we can do that using the typecasting, and both operations are supported in Python. Okay, well, the next thing I want to talk about is how we can build new tuples. Well, this happens when you have an old tuple, and then you find some of the values has to be changed. And then how do we do that? The answer is nope, we cannot do in-place changes, but we can build a new tuple, right? So when, for example, I have two tuples, well, and Byte Company and Byte Company, and then the 1974, and they reached the Lightning and Metallica, and then 1984. So those are pretty old things, and probably you don't know what they are. Well, they are albums, well, in the last century, and they were kind of popular in the 70s and 80s. But well, probably you guys don't know that because at that time people were still using this shape of the cassettes to enjoy the music, and you don't see them now. Okay, well, anyhow, my argument is, well, if I want to change some item in the tuple, and then how can I do that? Well, the answer is I have to build the new tuples. And how do I build new tuples? Say I want to change this one. So for the first one, bad company, that's okay. But for the second one, I want to change it to something else, and then I'm keeping the last one. So to build a new tuple, and the first thing you want to remember is, well, we can also use square bracket and then index to access the values in a tuple. And for example, if you want to do Metallica square bracket 0, and then you will get the first item of a tuple. Okay, so this syntax, it works for list, it also works for tuple. Now my plan is kind of clear. I want to keep this item, I want to change this one, and then I want to keep this item. So the bad updated will be, I'm reusing the bad 0. And then I want to plug in a new value as the second item, and then I'm using the bad 2 as well. So for this bad tuple, I'm reusing the first item and the last item. However, for the middle one, I'm updating that to a new item. But anyhow, I'm making a change, or I'm building a new tuple. Let me ask this again. So by creating the bad updated tuple, am I making a change, or I'm building a new tuple? The answer is I'm still building a new tuple, because for this bad tuple, it stays as is. I cannot do any in-place changes. But I did build a new tuple by reusing some of the existing values from the old tuple, right? Okay, well, in this is example we have seen before. Say if I want to change this value 4.56 to a new value 3.14, and I cannot do that because that is a in-place change, and we cannot do that in a tuple. Well, if we want to, of course we can recreate this tuple, right? And then here is just another way. Well, we want to reuse part of the old tuple. Say I want to change this value, so the first two values, I can keep them. How can I keep them? That is a slice. So I'm using the first slice to grab the first two items. And then I'm also keeping the last two items, so I'm making another slice. So, well, those are two slices from the old existing tuple. However, in the middle one, I do want to add a new value, but then it will be 3.14, comma, parentheses. Okay, well, this comma cannot be skipped, because if you skip that comma, and then Python is going to treat the 3.14 not as a tuple but as a float number. So, well, this kind of a tricky part about the tuple, because if you don't do this comma here, and well, this syntax looks also correct, but Python will just take that as a float number. Okay. Well, and here is another kind of confusing part about the mutabilities of tuple. Say I have the bad tuple again. And for this bad tuple now, I'm assigning a new value 10 to the bad, the name of the bad. Okay? Well, and if I do that, and you will find it works. So you may say, hey, Dr. Sang, I don't think your argument is correct because, well, you see, I change the bad. Well, and you say tuples cannot be changed. But how I can change the bad in this case? Okay, I'm going to explain this to you. Well, originally, we have the bad as a variable name, right? And then this variable name refers or points to a tuple, bad company, in 1974. Okay, so this is fine. And then if we are doing the second line, which is bad equals 10, what happened? It happens like this. So the bad now still the variable name, but now it's pointing to a new value 10. Okay, so my question is, well, it seems that we are changing something, but are we changing a tuple? Or we are changing the reference of a variable name? Okay, so eventually you will find we are changing the reference of the bad as a variable name. We are referring from the bad variable name to a new value 10. And what will happen later? Well, that tuple will become an orphan in the main memory, and then it will be erased eventually, right? So we are making a change of the reference of a variable name. However, we didn't really make any in-place changes on the tuple. So can this be done? Yes, this can be done, but we are not making in-place changes on a tuple. Okay, so this is how Python works, and this is how Python manipulates the main memory of our machines. Okay, well, here is something else I want to talk about. And previously, well, probably you have seen this kind of code. Like AB is 12 and 13. And then if you want to print A, print B, and then you got 12 and 13. Well, and then how do you flip the values of two variables? Well, and then there is an old way. Say, for example, let me say this one, A equals 12 and B equals 13. And then if you want to flip those two values, so you have to do a temp equals A. Well, temp is holding the value of A. And then you can say A equals B, and then B equals temp. Okay, so I'm using a temporary value to hold the value for A first, and then I'm assigning B to A, and then for the original A value, which is held by the temp, now I'm assigning that to B. Okay, so this is the old school way of flipping the values of two variables. But now, well, in Python, we have a handy way. So let's see that. Well, and that is a comma b equals b comma a. Well, what is that? A comma b. We are putting a and b together as a tuple, right? So a is the first value and b is the second value. And then we are assigning what? We are assigning the b comma a to a comma b. So for the b comma a, that is another tuple, right? So b is the first value and b is the first value and a is the second value. So in this process, I'm assigning the b's value to a, and also I'm assigning a's value to b. So we got those values reverted. Okay, well, this is a quick and handy way to revert the values of two variable names. And there's one more thing. One more thing is here. Well, what did we do? We did a comma b equals 12, 13. And you see what I did? I did a equals 12 and b equals 13. So those two things, they are exactly the same. They're equivalent. However, since we have the concept of tuple in Python, and this syntax is allowed it because we are assigning a tuple of 12 and 13 to a tuple of two variable names, a and b. Okay, so with the tuple and this kind of the change of the syntax is available in Python. And personally, I would say those are the cool tricks that we can do with Python. Okay, so I'm gonna pause the video here and I will see you in the next video.